The purpose of this video is to discuss how to do problem number 16 out of chapter 10. So in front of you, you see a cutout of problem number 16 from chapter 10. And what they want us to do is take a look at these two different diets and see if indeed the people that are on the Mediterranean diets, they're like low carb diets, if they lost more weight than the people on the traditional low fat diets. So the first step that we need to take is to go in and get the textbook data labeled different diets. And then we want to go about the business of attempting to set up a hypothesis. So first, let's go ahead and bring in the data so we can just sort of pause and think about what we're trying to do, and then we'll set up the hypotheses. So let's go get the data. So you can see I brought in the data, I fancied it up a little bit, I made it in purple and yellow, but basically it's the same as your data. And I've also labeled it, and this is very important. I've labeled it mu1 and mu2. Mu1 is the Mediterranean diet, or the low carb diet, and mu2 is the low fat diet. And this becomes very important as we move through the problem. So the first thing that I like to do is take a look at the average, standard deviation, and variance. So you don't have to do this, but for me, I find it easier to get my brain around it if I have a concrete example. So we can see here that the average for mu1 is 9.733, and the average for mu2 is 6.283. So I have just written that right here in my Excel document just to make it simple. So what we're trying to show is that this group right here, this mu1, is indeed different from mu2. So we can all look at that and see, well, 9.7 is definitely larger than 6.2. But the question that we have is, do the groups, when we include not just the mean but the variance as well, or the standard deviation around the mean, do those groups overlap? That's what we want to know. And essentially it sort of looks like this, a graphical depiction of this problem. And we've got the low fat diet mean weight loss here of 6.28 pounds, and we have the low carb weight loss diet of a mean weight loss of 9.733. So we know already that 9.733 is definitely larger than 6.28, but the question we're trying to ask is 9.77 enough larger than 6.28 such that these tails right here don't overlap so much that they're not really different? So what we're going to do is conduct a test to see if, not just if the means are different, but essentially we're conducting a test to see if the means and associated variation are indeed different. So first thing we want to do is write up our hypotheses. So our hypotheses in this case, our null and alternative, are going to be set up in using mu, because we've got whole and continuous numbers here. So we're going to write out our null and our alternative hypothesis, and then we'll go about the business of looking at the data, etc. So essentially what I have written out here is that the null is the statement of what is. So what is essentially that all diets are the same. Thus, we're really hypothesizing, the current opinion is that mu1 minus mu2 is going to be less than or equal to 0, because the null assumes there is no difference, or if anything, that the diet number 2, the low fat diet, the current diet, maybe even is better than this newfangled diet. So pause for a minute and think about what this says. It's, I think, a little counterintuitive, but we are stating what is. Then in the alternative, we're going to say mu1 minus mu2 greater than 0. That's going to be the alternative that we're trying to show. So you can see that my alternative here is exactly what I just said. Mu1 minus mu2 is indeed greater than 0, which is really what we're trying to show, and really kind of what we think, because if we were to just take our means and write them out, of course our number would be greater than 0, right? Because of course 9.77 minus 6.28 is indeed greater than 0. So now let's go ahead and take a look at Excel. So I've just taken a minute here to make sure that I write out what mu1 and mu2 is, and then I want to write out my hypothesis. So let's go ahead and put that in just so we know what we're at. So I just wrote out the hypothesis, and then the hypothesis and the alternative, and then I defined it as mu1 as the low carbon, mu2 as the low fat diet, which we've already done. Okay, so now what we want to do is conduct the statistical test. Now for this test, what we want to do is use a t-test assuming equal variances. So a t-test is just a way to test between two populations to see if there is an actual difference with when we consider both the mean and the variance around the mean. So we just go in here to data and then over to data analysis. I have to scoot this over, and to up here, let's see if we find the t's. T-test, we got paired samples, but this is not a paired sample. T-test, two sample assuming equal variances. And so for this one, we'll assume equal variances, or we'll say okay here. And then we've got our two columns of data. So this is, I don't know if it will let us have that, but let's try that. And we'll try this one too. It's always nice if we can get labels, so we got to put the label. And our hypothesized mean difference, remember, is 0, because that's what we said in our hypothesis. And we want to have our output right underneath this, so we'll put that right there, and we'll say OK. So what we want to know is if there is a difference between these means. Okay, so this is mean 1, mean 2, we got that, we got the variance, we've got the pool variance, we've got our degrees of freedom, which is 58, that gets at our power. And then we have this is our t statistic. So this is the value we're kind of looking for. This is what we're interested in, because this tells us basically, now this is sort of a gross statement, but whatever. Basically this is like the result of the z-test. We are looking to see how much difference is between these means. And indeed with a t-stat like 7.5, that is sort of, I'm using the term loosely, equivalent to being about 7.5 standard deviations away from the mean, which would suggest statistical significance, because our critical value for one tail, which is what this is 1.67. So we have way exceeded 1.67 with our 7.586. So that means that our groups are different. So let's just write that out so we know what we have found. So you can see I got it there. Our groups are indeed different. There is just no denying it. There's a big gap between our groups. Okay, so now we got to go back to our hypotheses and decide whether or not we reject the null, or we in favor of the alternative, or we cannot reject the null. So essentially what we make our decision based on our t-stat. So since our t-stat is greater than the critical value of 1.6716, we can reject the null in favor of the alternative. And with that, we can say that at the 5% significance level, the sample data suggests that overweight individuals on the low carbohydrate or Mediterranean diet will lose more weight than their counterparts on the traditional low fat diet. So there you go. I hope this was helpful. See you soon.